Complex numbers multiplication, type 3, by another complex number. So in these questions here, we're going to be asked to multiply two complex numbers by each other. So we saw that when we multiplied by a complex number by a constant, that we got either a dilation or a contraction. We saw that we multiplied by I, we had an anticlockwise rotation by 90 degrees, or when we multiplied by minus I, we got a clockwise rotation of 90 degrees around the origin. So when we multiply two complex numbers, in general, what we'll see is that it's the same as multiplying basic algebra. So we have 3 by minus 3 gives us minus 9. 3 by 2i is 6i. 4i by minus 3 is minus 12i. And 4i by 2i gives us 8i squared. Now we can see that it has to be in the form of a plus bi. So the minute we see any I squareds, we have to remember that I squared is equal to minus 1. So we should always have only a constant and an I in our answer. So we have minus 9, and then we're going to have minus 6I, and then we have plus 8 times minus 1. Gives us minus 9, minus 6I, minus 8. So our answer then is minus 17, minus 6I. So basically when we multiply a complex number by another complex number, then we say the product of two complex numbers is itself a complex number. So in other words, we say closure is preserved. Under multiplication. In other words, the product of two complex numbers is a complex number. Okay, so what we're going to do then is on page 292, we're going to do question 4, part 1, part 2, part 3, part 6, and then question 5, part 1, part 4, and part 5. So in division, it's a bit like rationalising the denominator with thirds, where we have to use conjugates. So the first thing we're going to look at here is what is the conjugate of a complex number? So a complex number is generally written as z is equal to a plus bi, and its conjugate is written as z hat or z bar. And this is where we change the sign of the imaginary part. So we just simply change the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. So change the sign of the imaginary part. So I am for imaginary part. So say, for instance, we have z is equal to 4 plus 3i. Then we would say the conjugate is 4 minus 3i. If we have a complex number minus 6 minus 5i, then the conjugate would become minus 6 plus 5i. If we have a complex number 6i, so 0 plus 6i, then the conjugate would be 0 minus 6i. So in other words, we just write down minus 6i. So it's really important to know how to use the conjugate, because when dividing complex numbers, then what we do is we multiply above and below by the conjugate of a complex number. And this because when we multiply a complex number by its conjugate, we end up with a constant. So if we look at one of these, so 4 plus 3i multiplied by its conjugate, 4 minus 3i. Then we end up with 4 by 4, which is 16, 4 by minus 3, which is minus 12i, 3i by 4, which is 12i, and 3i by minus 3, which is minus 9i squared. And of course, I squared is minus 1. So we end up with minus 12i plus 12i is 0, and minus 9 times minus 1 is plus 9, which gives us then 25. So you can see that the complex number multiplied by its conjugate gives us a constant every single time. Now, of course, if we were to look at what does that look like on the Argand diagram, how do we identify our complex numbers and its conjugate? Well, what you'll notice is if I had 1, 2, 3, 4, and 1, 2, 3i, then there's 4 plus 3i. And if I look at the conjugate, 1, 2, 3, so minus 3i, what we can see is that it's reflected in the x-axis. So our conjugate will always be reflected in the x-axis. So if we were asked to identify our complex numbers using our Argand diagram, look for the one that is directly below through the x-axis. Okay, so let's have a look then at using this information. So type 2, we're going to be asked to divide two complex numbers. So we're given z1 is equal to 11 minus 10i, and z2 is equal to 4 plus i, and we're asked three things. So divide z1 by z2, calculate the modulus of z1 and the modulus of z2, and then investigate if z1 over z2's modulus is equal to the modulus of z1 divided by the modulus of z2. So let's look at the first part. So the first part is saying z1 divided by z2. So z1 is 11 minus 10i, and z2 is 4 plus i. So of course, to divide our complex numbers, our rule is we multiply above and below by the conjugate of the denominator. So the denominator here is 4 plus I. So if I multiply the top and the bottom by the conjugate, well, the conjugate is 4 minus I. So multiplying at the top line there, we have 11 by 4, which is 44. 11 by minus I is minus 11i. Minus 10i by 4 is minus 40i. And minus 10i by minus I is plus 10i squared. On the bottom we have 4 by 4, which is 16. 4 by minus I is minus 4i. I by 4 is 4i. And I by I, minus I by I should say, is minus I squared. So again, we have to remember that I squared is equal to minus 1. So simplifying that then gives us 44 minus 51i minus 10. When I multiply I squared and replace that with minus 1, so minus 1 by 10 is minus 10. 16, and then minus 4i plus 4i is 0, and minus 1 is plus 1. So on the top, I end up with 34 minus 51i divided by 17. So that is basically 34 over 17 minus 51 over 17i, and 17 divides into 34 twice, and 17 divides into 51 3 times. So we should always write our answer as a plus bi, regardless of whether that, if 17, say, didn't divide into the top numbers there evenly, we would have to leave our answer in fraction form, but it should always be in the form of a plus bi. So always in form a plus bi. Okay, so that's part 1. So if we go back up here, part 2 then says calculate the modulus of Z1 and the modulus of Z2. Okay, so our Z1 was 11 minus 10i. So our modulus of z1 is the square root of a squared plus b squared. So that's your Pythagoras. It's the length of the complex number to the origin. So therefore that's the square root of 11 squared plus minus 10 squared. And that gives us the square root of 121 plus 100. So therefore the modulus of z1 is the square root of 221. If I do the same then for z2, well, z2 was 4 plus I, so the modulus of z2 is the square root of a squared plus b squared. So the coefficient of I there is 1. So therefore that gives us the modulus is equal to 16 plus 1. In other words, the square root of 17. Part 3 then says we have to investigate if I get the modulus of z1 divided by z2, is it the same as dividing the modulus of z1 by the modulus of z2? So in part 1 we've calculated z1 divided by z2 and we got it to be 2 minus 3i. So the left hand side here means we have to get the modulus of 2 minus 3i. So in other words, let's look at the left hand side first. So that's the modulus of z1 over z2. So that's the modulus of 2 minus 3i, which is the square root of 2 squared plus minus 3 squared. So that's 4 plus 9, which is the square root of 13. And then the right-hand side is the modulus of z1 divided by the modulus of z2. So the modulus of z1 is the square root of 221 over the modulus of z2, which is the square root of 17. And if I divide root 221 by root 17, or you can use your calculator, we end up with root 13. So therefore I can see that the left-hand side equals the right-hand side. In other words, that statement is true. It doesn't matter whether I get the modulus of the z1 over z2 or get the modulus separately and then do the division. It's the same answer. Okay, so let's have a look at some questions. We're going to go to page 295. And what you're going to do for me there then is question 4, part 1 and part 3. Question 5, all of it. Question 7. Okay, to do part 2. And question 9. We're going to do all of it. And that's it. And we'll have a look at the diagram questions in class then tomorrow.